All right, friends, welcome to the first section of Unit 3. How exciting. All right, today we're going to talk about a lot of vocabulary. So one, I hope you did your warm-up. And if you hadn't, I would say pause this video right now and go do your warm-up because it's really going to get your brain ready for all the vocabulary words that we're about to throw your way. Okay, and I mean that very seriously. So go do that right now if you have not done it yet. Our learning target today is to be able to identify transversals. So that's one of our vocab words, transversals. Okay, and then we're also going to have different angle relationships, okay, that are created when we have a transversal. Now you guys are like, I don't even know what a transversal is. That's right, you're about to learn. So transversals and angle relationships, and there's a lot of vocab that comes to do with those. So we're not going to actually do any calculating today. So for those of you who are not big fans of calculating, today is your day to be awesome. Let's think back, however, to last unit. We talked a little bit about parallel lines. We wrote some equations about parallel lines. And as we move forward in this unit, we're going to have some more parallel lines. So we're just going to kind of warm up today and get ourselves ready for these transversals and these angle relationships. So remember that parallel lines are lines that never intersect. And most of you at this point are good with that. Yeah, so they could look like this. They could look like this. All kinds of options. No big deal. What we have not told you yet is there's a mathematical symbol for parallel lines, and it looks like this. So if you ever don't want to write the words parallel or parallel lines, you can use this symbol. And conveniently enough, it looks like two parallel lines. So I could say, and I'm going to use them down here in a little bit, that line A is parallel to line B. All right, and that's how we would read something like this. So this is the symbol for parallel lines. Cool, you learn something new every day. Now, if we had a three-dimensional figure, which we haven't done very much, we're not going to do a whole lot right now. We're just going to play for a minute. This is what we call a triangular prism. We are going to look at some different parallel lines that exist in a three-dimensional world. So what lines are parallel to the segment AB? So first of all, we got to find AB. So where is that? Well, I find it right here. So if you have a straight edge, this is a really good time to find one and to get it out. I want any and everything that is also parallel to that same line. So my trick, you ready for my trick? Is to line up my ruler or my straight edge. And then I just kind of move it through my figure until I come to a line that lines up like that one right there. You see that? Boom. That one. What do we call that? Remember when we name a line, we're going to name it by 2 points. So this is line EF. All right? So we could say that EF is parallel to AB. Is that the only one you think though? Let's go find out. So we're going to continue going. Oop, I found another one. Boom, right there. DC. Okay, so some of you are really good at finding these visually. Some of you might need the help of a straight edge. All right, so now I want you to go try to find the lines that are parallel to CF. So use the same strategy I just used and see what you can find is parallel to CF. I'm going to give you a minute. All right, let's change colors for CF. So first let's go find CF. That's this one over here. Now, if I want to find what's parallel to it, I need to keep it at this angle and see if anything, so nothing on this side. So we have to keep moving. Oh, there's only one. It's this one down here. Is that what you got? These are parallel. So we would say that, what do we call that? DE is parallel to CF. All right, so you now can go find some more parallel lines. Let's see what we got. What about AD? What would be parallel to AD? How about this one here? What is parallel to AD? What do you think? Yeah, CB. That one. Alright, and the only lines we haven't used yet are these ones down here, which are AE. So I take this. Oop, there it is. Whoop, there it is. What up? Thank you, 90s. Alright, what was that? AE is parallel to FB. Okay? So, just kind of getting you used to looking at things from different perspectives, right? And seeing the different connections between the lines. Okay, so that was just kind of getting your brain ready. That is not the big portion of our lesson today, so don't commit too much energy there. Here is our big lesson, because remember our learning target was to be able to identify a transversal and its angle relationship. So let's really get into that part. So what is a transversal? Well, a transversal is a line that intersects two or more other lines. Okay, so in this situation, our transversal has to intersect two or more lines. Well, this line only intersects one line, and this line only intersects one line, but this line intersects two. So this is what we would call our transversal because it has two intersection points. So in our notes we would say line Z is the transversal. So here's its name right here. This is line Z, this is line Y, and this is line X. Okay? So what we notice is when two lines are cut by a transversal, we use this phrase cut by a transversal. Basically just means it's intersected by a transversal. When two lines are cut by a transversal, we get different angle pairs. So you'll see we've labeled these angles with numbers. So we got 8 angles here. We're going to talk about the different relationships we have. Okay, so if you did your warm-up, these are going to kind of be like, what? Duh. If you did not do your warm-up, you might be like, Okay, so make sure, again, if you didn't do your warm-up, you might want to go do that real quick. All right, our first one, I'm going to use colors because I don't love the way that this kind of came out. The first thing we want to look at here is some of our words. One of them is we have alternate interior angles. We have alternate exterior angles. We have consecutive or interior angles, and we have corresponding. So let's clarify what we mean by interior versus exterior. Okay, so when we say interior, we mean things that are in between the two lines. This is what we call interior. So right now we have 4 interior angles. Okay, 2, 6, 3, and 7 are what we considered interior. So logic would then tell us that exterior would be out here. And so we have 4 exterior angles, 1, 5, 4, and 8. All right, so those are the first distinctions you need to know. All right, So the other part we kind of talked about was alternate versus same side. Well, we're talking at that point with relation to the transversal. So if this is my transversal, right, I'm either on opposite or alternate sides of the transversal, or I'm on the same side of the transversal. So when we're talking about alternate versus same, that is with relation to the transversal. Okay, so hopefully that clears that up just a little bit. So now let's put all of our words together. Alternate interior angles. So let's start with the word interior. Interior means they have to all be in the interior, but they have to be on alternate sides of the transversal. So, interior, but alternate sides of the transversal. So 2 and 7. So angle 2 and angle 7. And angle 6 and angle 3. So let's fill out our description. 2, right, interior angles on opposite sides of the transversal. But the name kind of gives it away, right? Like the name it tells you alternate interior versus, in a second, alternate exterior. All right, let's do the next one. Alternate exterior. So all of our exterior angles were yellow, so we can only choose yellow options here because they must all be exterior. But they also must be alternate, so they have to be on opposite sides of the transversal. So we have options 1, 5, 4, and 8. So you might be thinking 1 and 5, and I can see why you might think that, but it's not. 1 and 5 are just normal supplementary angles. So let me clarify for you. When we say alternate exterior, we're going to go all the way to the other side. So 1 and 8. And I guess you could have thought that here too. You might have thought 2 and 6, but we're not. We're going all the way across here. All right, alternate. Not only are they on opposite sides of the transversal, they're on opposite corners. So that might also be a good way to think about the word alternate. Opposite corners. Okay? That's a good way to think about that. All right, so then the other pair would be 5 and 4. All right, moving right along. Okie dokes. So the next one we have is consecutive, which we also call same side interior. And we also have same side exterior, but they are not called consecutive, so we don't have it right here. So same side interior, which can be called consecutive. So when we know they have to be interior, okay, consecutive means one right after the other or right next to each other, and they have to be same side. So if we look here, interior angles that are on the same side of the transversal, those would be 6 and 7 or 2 and 3. Very good. Now we do have same side exterior, which we don't have right here, but I bet you're pretty smart and you can figure out what that is. Same side exterior would be what, 5 and 8, and then 1 and 4. Yeah, same side exterior. 1 and 5 would be on the same side of the transversal, but on the exterior. And 1 and 4 would be same side of the transversal, but on the exterior. All right, the last one is corresponding. Oh, hold on. I got ahead of myself. Let's go fill in our descriptions. Alternate exterior. 2 exterior angles on the opposite side of the transversal. I said all the words, I shouldn't write them down. My bad. And this one is interior. Angles on the same side of the transversal. Cool. All right, corresponding. This is the one that the name, if you know what the word corresponding means, it totally makes sense. But if you don't know what the word corresponding means, it won't make very much sense. So corresponding angles are two angles that are in the same position on different lines. Not different transversals, different lines. Same position, different lines. So let's go look what that means. So here is a line. And I'm going to say on top of this line, I have angles 3 and 7. Right? Below this line, I have angles 4 and 8. So on top of this line, I have angles 3 and 7. And to the left of my transversal, I have angle 3. And to the right of my transversal, I have angle 7. All right? But this line on top, I have angle 1 and angle 5. And to the left, I have angle 1. And to the right, I have angle 5. So the top left position is 1. And down here, the top left position is 3. So 1 and 3 are corresponding because they're both top left. Okay? 5 and 7 are both top right. 2 and 4 are both bottom left. And 6 and 8 are both bottom right. So let's get those written down. So we'd have angle 1 and angle 3. Angle 5 and angle 7, angle 2 and angle 4, angle 6 and angle 8. Okay, so it's with relation to the line. Top left, top right, bottom left, bottom right. Okay, with relation to the lines. All right, guys, that's the vocab. So all we do now is we practice that. All right, so you want to keep this handy? And we're going to do this example. That's really all it is. So use the figure below to classify the angle pair and determine the transversal that forms them. So really, we simplified this problem. There's only one transversal. It's transversal C. So it's just going to be C all the way down. Sorry about that. Okay, but if we're going to do angle pairs and their types, so we have 5 options, really 6 options for our types. And you're like, Miss, you only went over 4. That's right. So let's make sure we know them all. So we have alternate exterior. We have alternate interior. Okay, we have same side exterior, same side interior, corresponding, and vertical. That is still a thing. So don't forget that that's a thing. So those are our 6 options that we might be able to use when we are finding our angle pairs. So our first one is 1 and 5. Well, they're not on alternate sides, so I can get rid of both of the alternates. They are definitely same side. But if this is my interior, they're not both green. So they can't both be interior and they can't both be exterior. So it can't be those two. So I'm left with 1 and 5 are either corresponding or vertical. And I know for sure they're not vertical. Are they both top left? Top left? Yes. Corresponding. All right, 5 and 7. Oh, so interesting, because I didn't really talk about 5 and 7, right? I hinted at it earlier today, but 5 and 7 is just plain old supplementary. So I guess we could add that to our list. Five and 7 are supplementary. 4 and 2. 4 and 2. Well, they're not both green, so they're not both interior. And they're not both white, so they're not both exterior. So I can't do any of those. They're not both on the same position. So I have vertical and supplementary. 4 and 2 are vertical. I'm going to do a few more and then I'll let you try a few. Alright, 4 and 5. Whoa, 4 and 5 are both in the green. And the green means what? Interior. So I have these two options. Now, alternate interior or same side interior. Remember that has to do with where they are in relation to the transversal. Are they on the same side of the transversal or opposite sides? Well, 4 and 5 are on the same side. So these would be same side interior, which we also call consecutive. You need to know that vocab word. Consecutive. All right. 1 and 8. 1 and 8. Okay, they're both white, so they're both exterior. So I could have one of these two. Are they on the same side? They're not. 1's over here and 8's over here. So they're alternate exterior. All right, I want you to try the next 3. Pause and see how you do. All right, 3 and 8 are in the same position, bottom right, bottom right. They're called corresponding. 3 and 6 are same side, interior. 1 and 7 are same side, exterior. All right, we've got a few more. We're running out of space. Let's see if I can get these up here. All right, 4 and 7. Bottom left, bottom left. Corresponding. 2 and 6. They're not both the same color, so I can't do any of those. So it's either corresponding, vertical, or supplementary. 2 and 6. Well, they're not supplementary, they're not vertical, they're corresponding. Last one, 2 and 8. They're both the same color. They're both exterior. And they're both on the right side of the transversal. Alright guys, that's it. That's your lesson for today. Ta-da! Alright, go do your assignment and practice this because we are going to use this tomorrow to solve equations. Ta-da!